Picture a lump of rock about the size of a potato. Now pack it with some of the most valuable metals on Earth.
That is a electric vehicle battery in a rock.
It looks like a lump of charcoal.
Imagine a rock no bigger than a potato, yet packed with Earth's most precious metals. 5,000 meters beneath the ocean's surface, where sunlight never penetrates and pressure could obliterate a submarine, scientists stumbled upon something truly astounding. What first appeared as another deep-sea anomaly quickly revealed itself to be anything but ordinary. The incoming data suggested a phenomenon defying the very laws of nature, its estimated value hinting at over $3 trillion. It looked like a lump of charcoal, yet it behaved like a powerful battery, sparking a quiet frenzy among governments and billionaires funding secret missions. The scientists behind this discovery whisper of something that could fundamentally rewrite our understanding of life itself. What they found 5,000 meters under the ocean defies all prior expectations. The journey began in the Clarion-Clipperton Zone, or CCZ, one of Earth's last uncharted frontiers. Sprawling across 4.5 million square kilometers of seafloor between Hawaii and Mexico, this abyssal plain is larger than the entire European Union. Descending to 5,500 meters, temperatures hover just above freezing, sunlight is an alien concept, and the pressure exceeds surface levels by 500 times. It's the closest we can get to visiting another planet without leaving Earth. For decades, mining companies eyed this enigmatic region for its scattered treasures. Polymetallic nodules rich in copper, nickel, cobalt, and manganese, potentially worth billions. However, in 2021, a team from the Scottish Association for Marine Science, led by Dr. Andrew Sweetman, arrived with a different objective. They sought not riches, but air, specifically understanding how water flows through the deep sea muck, where some of Earth's most bizarre life forms manage to thrive against impossible odds. The team aimed to study how microorganisms cycle oxygen in these harsh habitats, providing insights into deep sea ecosystems and the potential impacts of human activities like mining. They deployed sophisticated landers, robotic labs that autonomously sink to the bottom, equipped with benthic chambers and oxygen sensors. The premise was simple: measure the rate at which mud microorganisms consume oxygen to determine biological activity. But the ocean had other plans. The initial readings were nonsensical. Instead of a steady decrease in oxygen as microorganisms consumed it, the sensors reported an increase in air levels within the chambers. Scientists initially dismissed it as an error. You learn to distrust your instruments when you're working at these depths, one researcher noted. Saltwater fouls equipment, tremendous pressure distorts metal, and cold impacts electronics. They checked everything, calibrated sensors, repeated trials, and dispatched fresh landers to different areas. Yet the impossible outcome persisted. Air levels were rising when they should have been falling. After 5 years of meticulous testing across multiple expeditions, the crew faced a shocking realization: something on the seabed was defying the known laws of nature in total darkness. Since photosynthesis, powered by sunlight, was the only known source of breathable oxygen, this discovery in the sunless abyss was akin to finding underwater fire. Radical explanations were considered. Were certain minerals releasing oxygen through a reaction with seawater? Was an unidentified chemical reaction at play? Or perhaps a whole new form of life that produces oxygen in ways we don't understand? The implications stretched far beyond academic curiosity. Oxygen forming without sunlight or living organisms challenged our fundamental understanding of deep-sea ecosystems. It could shed light on how life survived in Earth's early history, when oxygen was scarce. It even raised the tantalizing prospect of life on ocean worlds like Europa or Enceladus, where sunlight never penetrates, but life-sustaining chemical processes might exist. The CCZ transformed from a promising mining location into a natural laboratory unveiling unseen processes. The very metal nodules desired by miners, they suspected, might be central to this enigma, interacting unexpectedly with salt water. This discovery served as an alarming reminder that despite our advanced technology, profound mysteries still lie hidden in the deep ocean. The revelations deepened when the study team reviewed recent readings from their deep-sea drones. The seafloor itself was actively transforming into complex geometric forms that defied all natural explanations. It wasn't merely inert beneath 5 kilometers of crushing black water. Spirals as precise as a nautilus shell emerged from the mud. Grids with almost perfect 90-degree angles scattered outward like city plans. Intricate tessellations formed by interlocking ridges. This organization didn't match the surrounding seabed's mineral composition. The rock seemed to have deliberately folded itself into something something purposeful. Sweetman, adjusting his spectacles, observed, "This isn't random erosion, this looks designed." Discomfort grew as the team compared images taken just hours apart. The patterns were subtly but definitively shifting, ridges stretching like slowly developing crystal fingers, grids expanding, spirals tightening their curves. Time-lapse photography captured the astonished stillness of the seabed reconstructing, itself with glacial care. "We're not studying geology anymore," a crew member said. "We're watching the Earth think in slow motion." Electromagnetic data revealed an even weirder connection. Minute variations in the local magnetic field precisely matched each subtle change in the patterns, indicating a hidden link between shape and energy. The changes followed a clear rhythm, a burst of energy followed by motion, then quiet, like a sleeping giant's heartbeat. Night after night, the team ruled out every traditional explanation. No heat signals disproved hydrothermal activity, no chemical traces or gas emissions, no currents to explain tidal effects. Yet there was undeniable physical proof of a force changing the ocean floor. Even more terrifying, survey maps from decades prior showed these patterns, albeit less distinct and simpler. This wasn't new. It had been expanding, growing, evolving under human notice for an unknown duration. And now, under the gaze of the researchers' cameras, the patterns seemed to shift more quickly, as if reacting to their observation. In the control room, an unanswered question hung in the air. Were they participants or merely observers? Confronted with the perplexing oxygen readings, the first logical suspect was microbiological life. The deep sea, despite its harshness, teems with microbes, many of which survive without oxygen or sunlight, relying on sulfur, methane, or iron-based chemical processes. So, Dr. Sweetman's team hypothesized that an unusual microorganism might be the answer. To test this, they embarked on a fresh round of experiments, seeking to eradicate all life within the chambers to see if the phenomenon persisted. They applied biocides to the benthic chambers, substances known to neutralize microorganisms by disrupting cell membranes or metabolism. Essentially, they sterilized the mud to ensure no living thing could skew the findings. This was a critical step. If oxygen levels still rose after eliminating all biological life, then something else, something non-living, had to be responsible. Carefully, the treated chambers were lowered once more to 5,000 meters. The sensors thus began collecting data. Aboard the research vessel, scientists anticipated either constant or gradually decreasing air levels without microbial activity. But when the data returned, the findings were anything but typical, and they would indeed rewrite history. The oxygen content of the sterile enclosed room still increased, slowly but unequivocally. The pattern was undeniable. Despite the removal of all microbiological suspects, the odd trend continued. This was no longer just a strange readout or malfunctioning equipment. The observation was routine, supported by strict controls, and reproduced in carefully monitored settings. Yet it made no traditional sense. The scientists intensified their efforts, performing further controls, repeating sterilization with various techniques and dosages, shifting chamber placements and sizes across different CCZ regions. Regardless of their attempts, the outcome remained the same. Oxygen was appearing where it shouldn't. The mystery deepened. If not microbes, then what? Dr. Sweetman and his associates compared notes with other oceanographic teams, geologists, chemists, and deep-sea biologists examining historical data sets. Was a chemical process generating gases a never-before-observed reaction between silt and salt water? Or a completely different explanation? The absence of biological reasons was disturbing. In aquatic systems, life is typically the wild card, leading to unforeseen consequences and confusing data. But with the microbial card removed, the researchers faced a more difficult reality. They were observing a process that didn't behave like anything previously seen in marine sediment investigations. It was like pursuing a ghost, yet the data was honest. Oxygen was slowly and silently rising inside caverns buried beneath thousands of meters of water. Simultaneously, the study team felt an increasing excitement. This was the start of something far more significant than a singular occurrence. Whatever caused the rise in air levels seemed extensive, reliable, and constant across their test locations. It was an occurrence that begged for a fresh interpretation. Now, the researchers had a new question. Beyond economic potential, what else might the seafloor be concealing? The enigma of increased oxygen levels persisted, lacking obvious biological causes or satisfactory chemical solutions. The group persevered, driven by curiosity about the unseen force subtly changing the deep sea's chemistry. They were certain only that something non-living was mimicking respiration, exhaling air in the dark environment at the ocean's bottom. It was unexpected, an ongoing surprise. The electrical clue arrived in 2022. During a deep-sea mining presentation, Dr. Andrew Sweetman heard a speaker casually refer to something discovered on the ocean floor as batteries in a rock. For Sweetman, it was the kind of casual remark that halts everything. His team had been gathering enigmatic data from the CCZ for over a year. While the batteries in a rock was a cliche used to explain complex mineral behavior, it resonated. What if these lumps, previously regarded as inactive, were active? The team knew that salt water interacting with certain minerals could produce small electrical currents. Their testing yielded startling results. Under some circumstances, their specimens showed signs of little electrical currents, not tangible, but present. This was fascinating, completely altering the perception of these deep-sea components. They weren't just metal deposits, they were active participants in their surroundings. This finding raised a ton of new issues. What effects does this electrical activity have on the odd animals that inhabit these zones? What part does it play in the chemistry of the deep ocean? Most importantly, what unanticipated consequences can mining these objects have on this fragile ecosystem? The remark, it turned out, was more true than anyone had thought. It reminded scientists that even in the deepest recesses of the Earth, mysteries are only now being comprehended. We must understand these surroundings completely before we begin to alter them. There are still many surprises in store for us in the deep ocean. No team member was yet prepared to make public speculations. The science was still developing, the phenomenon too elusive. But what was previously dismissed as geological background was suddenly receiving all their focus. They had discovered a clue, not a conclusion, but a fresh, critical avenue for research. Later, in the laboratory aboard the research vessel, hovering hundreds of kilometers from any shoreline, something unexpected occurred. Amidst routine diagnostics for voltage differentials, current variations, and electrochemical gradients, the equipment detected an anomaly, a low-level, steady electric signal of about 1 volt. It may not seem like much, far less than required to light a lamp, but for scientists working thousands of meters below the surface, where chemistry, pressure, and temperature are known to be stable and predictable, it was enough to spark profound questions. Where did 1 volt come from? No electricity sources were in the area, no organisms large enough to produce the charge, no movement, no warmth. It seemed like nothing at all should be generating energy, yet the current stabilized. Nor was this an instance of instrument error. The group performed many checks, even switched out equipment. The outcomes remained unchanged. Deep in the shadows, something was driving electrons in one direction. It was steady, slow, and silent, easily missed unless specifically sought. But now that it had been located, it was impossible to ignore. The possibilities of just 1 volt were even more fascinating. Even a small electric current can stimulate chemical processes under the correct circumstances. That's electrochemistry at its most fundamental. With sufficient time, even low voltages can significantly alter a solution's molecular composition. It's how seawater causes metal to rust, how hydrothermal vents produce life-supporting substances, and the invisible way energy moves across apparently inert regions. The crew couldn't determine what was initially causing this current. No moving parts, no biological agents like electric eels, no temperature differences, nothing fit the typical models. The surroundings themselves seemed strange, or perhaps some self-wiring. Rumors circulated among the crew of electrochemical reactions never before examined in this environment, possibly only visible under the unique circumstances and pressures found 5 kilometers below the ocean's surface. The researchers didn't discuss the discovery publicly, not because they were concealing it, but because they simply didn't know what to make of it yet. However, the scientific community now understands that even a tiny voltage in the deep water can have a huge impact. It alluded to opportunities that went far beyond the current objective. What if in locations like this, energy were being produced organically in ways beyond our present comprehension? What if the deep bottom was something more dynamic, more active, rather than merely a cemetery of geological history? All of a sudden, that 1 volt rising silently from the abyss became the loudest signal of all. Scientists have unveiled one of nature's best-kept secrets in the deep Pacific Ocean: rocks that breathe oxygen into the ocean without the aid of sunshine or living things. This shocking finding in the Clarion-Clipperton Zone is insane and rewrites history, fundamentally changing our understanding of how oxygen moves across Earth's most inhospitable places. For years, strange oxygen measurements from seabed tests perplexed marine experts. Sensors inexplicably detected oxygen levels growing within measuring chambers at depths greater than 5,000 meters, where sunlight never reaches and pressures could crush a submarine. This was illogical, as all known forms of oxygen generation require photosynthesis from plants or bacteria. Here, however, oxygen was appearing where none should. Dr. Andrew Sweetman's team has finally solved the case. The solution lies in the seafloor's potato-sized metallic nodules. These polymetallic nodules, already sought by mining corporations for their abundant manganese, nickel, cobalt, and copper deposits, are acting as nature's deep-sea batteries. They are utilizing their inherent electrical potential to separate seawater molecules through electrolysis, the same fundamental chemistry industrial facilities employ to produce oxygen and hydrogen. When the nodules contact salt water under the intense pressure of the deep ocean, their distinct metal composition generates microscopic electrical currents. These currents are just powerful enough to split water molecules into their constituent gases, oxygen slowly bubbling into the surrounding environment and hydrogen dissipating into the water. This dark oxygen synthesis is a completely new type of natural oxygen production. It is entirely geochemical, a chemistry and physics trick taking place in nature's high-pressure laboratory, as opposed to the biological processes we've known. For ages, the ramifications affect several scientific fields. To marine scientists, it implies that deep-sea habitats could have oxygen sources we never considered, possibly supporting life in ways we don't fully comprehend. Astronomers are now intensely interested in the implications for the hunt for life. On ocean worlds like Europa, where comparable metal-rich seafloors may produce oxygen without sunlight, geochemists must now integrate this process when modeling Earth's ancient waters, as such oxygen generation may have occurred long before. Photosynthesis. However, this innovation raises serious environmental issues. The CCZ is the epicenter for planned deep-sea mining activities that aim to target these exact nodules. Mining may inadvertently change the oxygen levels that deep-sea life has relied on for thousands of years, with unknowable repercussions for one of Earth's remaining pristine ecosystems. Dr. Sweetman observes, "This isn't just about scientific curiosity. We have discovered a basic Earth function that was concealed in plain sight. We must now comprehend it before we may interfere with it." These metallic deep-sea stones serve as a potent reminder of how much we still don't know about our planet, and why the last frontier could lie in the murky depths of our planet's seas rather than in space. The finding forces us to reevaluate our basic understanding of the chemistry that supports life, as well as the conditions under which it may survive. History has been rewritten. The discovery of dark oxygen has upended the fundamentals of ocean research. The production of oxygen, necessary for the majority of life on Earth, may now be accomplished without the need for sunlight, photosynthesis, or even living things. According to new research deep under the ocean, this chemical process has never been observed before, propelled by electrical energy from mineral-rich stones. It's not only a scientific advance, it's an epiphany. If this is how oxygen can originate in the most severe and gloomy places on our planet, what else may be possible? Previously believed to be inhospitable to life, Mars, Europa, and Enceladus may perhaps be more livable than previously believed. The catch, though, is this: the same polymetallic nodules that cause this process are the core of the expanding deep sea mining sector. Businesses like the Metals Company are working to mine these ancient rocks for their rich metals, essential components for building renewable energy infrastructure and batteries for electric cars. This creates a serious conundrum. Could the removal of these nodules harm a naturally occurring oxygen supply that we hardly comprehend? Before we ever find ecosystems that depend on it, may we destroy them? What began as a quest to monitor the oxygen content of the bottom has evolved into a race against time. There is now pressure on scientists to learn more about this secret system before it is destroyed or changed irrevocably. Once thought to be a dead desert, the deep sea is turning out to be far more vibrant and enigmatic than anybody had anticipated. We could have discovered the secret to comprehending life, not just on Earth, but also on other planets, 5,000 meters below the surface, under the quiet and pressure of the Earth's abyss. In every way possible, what scientists found is amazing, and it is up to us what comes next. If oxygen can form in the deepest, darkest parts of our ocean, do you think it could exist elsewhere in our solar system? Share your thoughts in the comments below. Thank you for watching this video. See you in the next one.